In this video, let us consider the microscopic features of bone. I am grateful to Professor Michael Horsch of University of Michigan Medical School for providing the images of histology sections used in this video. Bone is a rigid, mineralized vascular connective tissue capable of repair and regeneration. It provides support and protection. Here, we are seeing a cross-section of ground bone. Bone is made up of cells, extracellular matrix, and its coverings and bone marrow. Extracellular matrix is in turn made up of water, which makes up about 20% of the weight of the bone. Organic material, which makes up about 30% of the dry bone weight. And inorganic minerals, which make up about 70% of the dry bone weight. Organic matrix is predominantly made of type 1 collagen and various non-collagenous proteins and glycoproteins like osteonectin, osteocalcin, proteoglycans like biglycan and decorin, osteopontin, and various growth factors. Inorganic matrix is mainly made up of hydroxyapatite crystals and calcium carbonate and calcium phosphate. We also find trace amounts of various ions and minerals. There are various types of cells in the bone. The osteoprogenitor cells are the mesenchymal stem cells. Osteoblasts are the basophilic cuboidal cells found in the newly forming bone. They synthesize, deposit, and mineralize the bony matrix. They are derived from osteoprogenitor cells. On the endosteal surface in the quiescent bone, these osteoblasts will form flat bone lining cells. We also find osteocytes in the bone. These are faintly basophilic ellipsoid cells seen in the mature bone. They maintain the bone matrix. These are derived from osteoblasts, or these are matured osteoblasts. In addition, we find osteoclasts. These are polymorphic cells with up to 20 nuclei with a ruffled border located in Hauschup's lacunae or in resorption bay. These cells help in removing the bone during remodeling, and they are derived from myeloid stem cells. Bone is covered by an outer periosteum, which is made up of dense collagenous connective tissue layer. It has few osteoblasts, osteoclasts, and osteoprogenitor cells. This periosteum is tethered to the underlying bone by means of collagen fiber bundles called as Sharpie's fibers. Periosteum helps in appositional growth as well as in repair of fractures. On the internal surface, bone is covered by endosteum, which is thinner and more cellular layer, which is predominantly made up of osteoblasts and osteoprogenitor cells. This endosteum lines all the inner cavities, including Haversian canal and marrow cavity. It helps in maintaining calcium homeostasis. In addition, bone has bone marrow, which can be red bone marrow, made up of blood cells in various stages of development in supporting framework of reticular fibers and reticular cells. This red bone marrow is found in young bones. In case of adults, it is mainly found in sternum and iliac crest. In older bones, this red bone marrow is replaced by yellow bone marrow, wherein the blood cells are replaced by fat cells. Based on the organization, there are two types of bones, that is woven or bundle bone. Here, the collagen fibers and hydroxyapatite crystals are arranged irregularly, forming an interwoven meshwork. This type of bone is found in the younger bone or in the bone which is undergoing repair. Osteoblasts are the main type of cells here. The second type of bone is the lamellar bone. Here, the collagen fibers are arranged regularly with a regular orientation in each lamella. And between the adjacent lamellae, these fibers make an angle of up to 90 degrees. This lamellar bone is found in the mature bone, and osteocytes are the main type of cells here. Various types of lamellae are found in this mature bone. Concentric lamellae are found around the Haversian canals in the Haversian systems. Circumferential lamellae are found on the periosteal or the endosteal surface. Interstitial lamellae are found in the space between Haversian systems. Here we are seeing circumferential lamellae on the periosteal surface. We are seeing concentric lamellae of the Haversian systems, and we are seeing interstitial lamellae between the Haversian systems. This mature lamellar bone, based upon where it is located and how it is arranged, is further classified into two types. The outer dense cortical bone or compact bone. Here, the Haversian systems are arranged parallel to each other along the long axis of the bone. Blood vessels are seen in the Haversian canals as well as in Volkmann's canals. And these Haversian systems are surrounded by periosteal and endosteal circumferential lamellae. The second type is the trabecular bone or cancellous bone or spongy bone. This is made up of bars or spicules of bones with intervening marrow cavity, and this trabecular bone is found mainly at the ends of long bones. There are no definite osteons or Haversian systems here, no vascular canals, either Haversian canal or Volkmann's canal, and nutrition to the osteocytes is mainly by diffusion from adjacent marrow vessels. Each bar of bone is surrounded by endosteal tissue. Here we are seeing the Haversian systems or osteons in the cortical bone, which are the cylindrical structural units of the cortical bone. They appear round or ellipsoidal in cross-section of the bone. Diameter of each of these Haversian system varies from 100 to 400 microns, such that no osteocyte is more than 200 microns away from the blood vessel in the Haversian canal. Each Haversian system contains a central Haversian canal, which are lined by bone lining cells and collagen. They are perforated by canaliculi. These Haversian canals contain capillaries lined by fenestrated endothelium and non-myelinated nerve fibers. Each Haversian system is made up of 5 to 20 concentric lamellae. Each lamella is made up of collagen fibers which are arranged with regular orientation in a single direction, and hydroxyapatite crystals are found between these collagen fibers. Haversian systems show dark lacunae containing osteocytes and canaliculi that contain processes of these adjacent osteocytes, and these canaliculi form the pathway for diffusion of metabolites between the blood vessel in the Haversian canal and the osteocyte. Haversian canals connect with each other and with the adjacent bone marrow cavity via the transverse or oblique vascular channels called as Volkmann's canals. They run at right angle to the axis of Haversian system and also the axis of bone. They transmit blood vessels and form the channels which connect periosteal vessels with vessels in the Haversian canal and the medullary cavity. Osteons are separated from their neighbors by cement lines or reversal lines. These mark the limit of bone erosion before the new osteons are laid. Resting lines, which are not shown in this picture, are also present. They mark the area where the growth had been stopped for a while without erosion and then resumed. Both these resting lines and reversal lines are basophilic in H&E sections with high content of glycoproteins and proteoglycans with little or no collagen. This is a longitudinal section of bone, ground bone, showing Haversian canals. We are seeing lacunae and the canaliculi here. This is a magnified view of the longitudinal bone showing lacunae and canaliculi. Here we are seeing the Volkmann's canal connecting the adjacent Haversian canals. So recalling whatever we have seen so far, bone is a rigid, vascular, mineralized connective tissue capable of repair and regeneration. It's made up of cells, extracellular matrix, and covering layers of periosteum and endosteum with bone marrow. Extracellular matrix contains water. Organic matrix made up of collagen and non-collagenous proteins, glycoproteins and proteoglycans, and inorganic minerals, bulk of which is made up of hydroxyapatite crystals. Bone cells are osteoprogenitor cells, osteoblasts, bone lining cells, osteocytes, and osteoclasts. Cylindrical structural unit of cortical bone are the osteons or the Haversian systems. These contain a central Haversian canal surrounded by concentric lamellae, which are made up of collagen, organic matrix, and hydroxyapatite crystals. And they show lacunae with osteocytes, which are connected by canaliculi. Thank you. Hope you enjoyed this video. You can also visit the site for similar histology videos.